So today we're going to look at some one variable application problems, in other words, mixture problems. All these are done fairly similar to each other. They all involve quantities having associated values for each quantity, and then you multiply those out and write an equation. So we've got a dimes and quarters type problem, nickels, dimes, pennies, quarters. Any money type problem for the most part can be done this way. What I like doing is setting up a chart. So what I'll do is I'll take and say what I've got is I've got dimes and quarters, and I have a number of dimes and a number of quarters. I've got a value per coin, and I've got a total value. So in this case, it says I've got 255 in dimes and quarters, and I have 8 more dimes and quarters. Well, let's start here with the number of dimes and quarters that I have. I don't know anything about the quarters. I'm going to call that my variable x, but I have 8 more dimes in that. So now what I've done is I filled in the box for the number of coins that I have. I know the value for each dime, that's 0.1, or I could do this in pennies. I'm going to do it in pennies. It just makes life easier. So I'm going to call each dime 10 pennies and each quarter 25 pennies. Now if I want to find out my total, I multiply the number of coins I have by the value per coin, and I get a total value. So this is 10 times x plus 8. And this is 25x. Now, this is my total dollar value, and I have a total dollar value here of 255. So from this chart, I write my equation. I say 10 times x plus 5, or x plus 8, those are my dimes, plus my quarter value, 25x, is equal to my total dollar value of 255 pennies. And distribute through, so I have 10x plus 80 plus 25x equals 255. I combine my like terms, that's 35x plus 80 equals 255. I'm going to subtract 80 from both sides, and when I do that, I end up with 175 is equal to 35x. And now I'm going to divide both sides by 35, and I end up with x equaling 5. So what does x represent? Well, here's my x value. So this 5 must relate to the number of quarters that I have. And the question asked, how many dimes do I have? So I have to take 5, add that to 8, you'll see right here, and that gets me 13 dimes. This is very similar, except we don't have pennies, dimes, nickels, quarters. We have values for certain amounts of coffee. One $3 per pound, one $3.50 per pound, and we're trying to create a 325 pound bag. All right. So this is a little bit different, but it still involves money, and there's still quantities for each. So here we go. In this case, we have 3 items, not 2. We have the $3 pound mix, we have the 350 pound mix, and we have the 325 pound mix. And we need to know the number of pounds we have, the dollars per pound, and the total worth of the mix. Well, the dollars per pound is easy. This is 3, 3.50, and 3.25. Now, the amount of each They say, how much coffee costing 3 pounds? I don't know. That's X. Should be mixed with 5 pounds of coffee costing $3.50. I know exactly how much there is here. And we want to get a mix of $3.25. Well, if I've added X pounds of this bag to 5 pounds of this mixture, then what I create is I create a total of X plus 5 pounds of this new mix. Now, to get my total, again, I'm going to multiply across. Because think about it, if I had 10 pounds at $3 a pound, that would be 10 bucks. But I don't know how much I have of this, so I multiply and I get 3x. In this next case, I take and multiply 350 times 5, and I end up with 17.5. Then in this last case, I'm going to distribute that, so I have 3.25 times x plus 5. Now, when I write my equation, notice I added these two quantities here to create this new quantity here. So when I solve, I have 3x plus 17.5 is equal to this new quantity, 3.25 times x plus 5. First thing I'm going to have to do is probably distribute this. So I'm going to need to know what 3.25 times 5 is equal to. So I have 3.25x plus 16.25 is going to equal 3x plus 17.5. Now, I've got a choice. I can either bring the 16 over or the 3x over. I can do them all in one shot if I really wanted to, so I'll subtract 3x here and 3x here. I'll subtract 16.25 here and 16.25 here. This is going to leave me with 0.25x on the right side, and on the left side I'm going to have 1.25. So now I divide 0.25 by either side. I end up with 5 equaling x. Doesn't mean 5 is always going to be our answer, but in this case it is. So at this point, they wanted to know how much of the 3-pound coffee I have to put in. The 3-pound coffee is my x value, so I say 5 pounds of 3-pound, $3 per pound coffee. More money? We've got Jack selling tickets for a game. The adult tickets cost $2.50 each. The student tickets $1.10. Total number of tickets sold was 105. This is very similar to what we just did. So in this case, we have two types of quantities. We have an adult ticket and a student ticket. I have adult tickets being $2.50 each, and a student ticket being $1.10 each. Now, here's the trick in this problem. We know there's a total of 105 tickets sold, but I don't know how many adult tickets and I don't know how many student tickets. I have to call one of them a complete unknown, and it doesn't make a difference which one it is. So I'm going to call X my adult tickets. Now if I have 105, think about it. What if I had 5 adult tickets? Then I'd have 100 student tickets left. How did I get that? I subtract what I used from what I had, and I have what's left. If I had, let's say, 10 adult tickets sold, I'd have 95 student tickets, etc., etc. So if I have X adult tickets, then I have 105 minus X student tickets sold. So that's the trick on this problem. Neither one is 105. It's 105 in total, and if I add these two quantities up, x plus negative x is 0, and I have 105 total tickets. So now to get my dollar value, this is the number, I multiply, I get 2.5x, and I get 1.1 times 105 minus x. These two totals in sales go to my total dollar value sold of $202.30. So now I write my equation, 2.5x plus 1.1 times 105 minus x equaling 202.30. I'm going to take and distribute. So I have 105 times 1.1 gives me 115.5. Minus 1.1x, and yes, we are using decimals because that's how the problem started. I'm going to combine like terms. 2.5 minus 1.1 is 1.4x plus 115.5 equals 202.30. Now I'm going to subtract 115.5 from both sides. Get 1.4x is equal to 86.8. Divide both sides by 1.4. And I'll end up with x equaling 62. So once again, I have to figure out what the heck x relates to. X is the adult tickets. So I had 62 adult. And I need to know how many students I have. So 105 minus 62 is going to be my student tickets, which gets me 43 student. Alright, now this problem is very similar to the coffee problem. It says this kid's doing a chemistry experiment where he's mixing a 30% solution of this copper sulfate, and he's got 40 milliliters of a 25% solution, and we want to know how many milliliters of a 60% solution should he add to this 40% solution to make a 30% solution. So this is a dilution or a concentration type problem. All right, but it's done the same way as the coffee problem. We have a situation where we have three quantities, and you're trying to get in the end this 30% solution. All right, and we're starting with a 25% solution, and to that we're going to dump in a higher percentage solution. We're going to dump in a 60% solution. It's like, let's say you're making Gatorade, and you start out with, 2 scoops of Gatorade, and you've got a really light looking drink, but you want a little more taste to it, so you're going to add some more scoops of Gatorade and it turns darker. That's kind of what we're doing. We're going from that light 25% Gatorade solution, adding a couple more scoops to get a higher percentage of Gatorade in that glass of water. All right. So what we want to do is we want to put our percentage in the middle. That's like our dollar value per. So that's 0.25 since it's a percentage, 0.6. Once again, a percentage, and 0.3. And it told me how much 25% solution I have started with, 40. We're going to add an unknown amount to that, which is x. So if I add x to 40, I end up with an x plus 40 amount. We multiply across to get our total, and we multiply 40 times 0.25, that's going to be 10. 0.6 times x is 0.6x, and then I have 0.3 times x plus 40. And now once again, I dump these two quantities together to equal this last quantity. So I set my equation up as 10 plus 0.6x is equal to 0.3 times x plus 40, and I'll have to distribute. So I have 10 plus 0.6x equals 0.3x, and then 40 times 0.3 is just 12. So once again, I'm going to get all my variables to one side, all my constants or numbers to the other. I'm going to subtract 0.3 from both sides, and then I'm going to subtract 10 from both sides. The 10's reduce out. I'm left with 0.3x equaling 12 minus 10 is 2. Going to divide both sides by 0.3, and 2 divided by 0.3 is equal to 6 2/3 is equal to x, and 6 2/3 corresponds to the x value, so that's the 60% solution. We're working in milliliters. So what I'm doing is I'm adding 6 2/3 milliliters of a 60% solution. Another solution type problem, he wants to mix up 60% and 35% solutions to get a 50% solution. So again, the 35% is like that weak Gatorade, the 60% is stronger Gatorade. We're going to add probably a lot more 60% to the 35% in order to get the whole thing to 50%. So let's make our chart again. We have three quantities. The number of liters we're adding, milliliters in this case, the percentage, multiply across, get a total. We're combining 60% to 35% in order to get a stronger 50% solution. Once again, percentage for each are given to us. And it said he wants to mix quantities of each amount to get 80 milliliters of this 50% solution. So in the end, I have 80. This problem is a lot like the adult and student ticket problem. I end up with 80 total. One of my unknowns has to be x. I'll call it this guy here. And then the other guy has to make sure that whatever I have put in already, the remaining part has to add to 80. So if I used 1 here, I'd have 79 here. If I use 10 here, I'd have 70 here. In other words, I'm subtracting what I've used from 80 to get what I have left. So the top, once again, is 80 minus x. Multiply across, get 0.6 times 80 minus x, 0.35x, and 50% of 80 is 40. Write my equation. These two are combining to equal a total here. So I have 0.6 times 80 minus x plus 0.35x is equal to 40. I'll distribute. 80 times 0.6 is equal to 48 minus 0.6x plus 0.35x is equal to 40. I'm going to combine like terms. So I have 0.35 minus 0.6 is equal to 0.25 of the negative type. And that's equaling 40. Subtract 48 from both sides. 40 plus negative 48 is negative 8 is equal to negative 0.25. And if I take and divide negative 8 by 0.25, I get x equaling 32. And x, once again, corresponds to the 30% solution. So I have 32 milliliters of my 35%. And then I want to know how much of the 60% I used. So if I had 80 to begin with, then I had 48 milliliters of my 60% solution.